Welcome, and thank you for coming tonight. I'm Doug Swartz with Fort Collins Utilities. Energy Efficiency for Home Comfort, Finding Solutions, Part 2. We're talking about home performance, energy efficiency, comfort. This is the second in a two-part series. I'm going to give you a one-slide review and a little bit about Part 1, so you get caught up on that. But we're going to be focusing tonight on the solution side, that is making improvements to your house, participating contractors who can do those improvements, rebates, and things like that. I'm going to be your first speaker talking to you about these things from a programmatic perspective. You're going to learn more about how the new Fort Collins Home Efficiency Program works, what it offers, how you participate, and so forth. And that'll be followed by Jeff Grazier, who's a home performance contractor and actually one of the auditors on our program, bringing you stories from the field. What does he run into? What are some examples of the types of problems that he solves? I think he'll be addressing some common ones as well as some less common ones. And I think it will help you understand how this program's a little bit different than some you may be familiar with. Okay, so we're going to be talking about the Home Efficiency Program. This is pretty much a brand new program. We rolled out the first pieces in January. And the contractor side that we're talking about tonight is really just coming online now. So this is brand new. And the tagline is Discover Your Home's Potential. It's all about trying to make homes work better for you. The website for the program's listed there. It's fcgov.com. So like Fort Collins Gov, fcgov.com/home efficiency, all tagged together. Go there to check out the fundamentals. It'll remind you of what we talked about tonight. This program comes to you from the home performance perspective, and you're going to see this set of glasses pop up a few times. And this represents the fact that this program looks at things through those lenses. We developed this program in response to a lot of things we've learned over the past couple of decades, and it hasn't just been us learning this. People all over the country who work in this field, whether they be contractors, whether they be sponsoring organizations or so forth, have learned over time that houses are pretty darn complex. They're not as simple as we thought they once were. And we need to design programs in ways that deliver results. That's what really this performance stuff is all about. We need to understand the building science, how heat flows, how moisture flows, how air flows, and how those things work together as a system. Because if we forget that, sometimes we fix one problem and cause another problem. In the past, sometimes there's been too much emphasis on treating the symptoms, putting Band-Aids on things, if you will, rather than getting to the root causes. And sometimes those solutions don't work very well. So a focus of this program is really digging a little deeper to find out what's really causing the problem, and let's figure out how to fix that. And then importantly, we're going to continue to ask this question. This gets to the heart of performance is, does it work? Did the solution that we installed solve the problem? Does the equipment we installed operate at rated efficiency as it's installed in the house? Does the insulation with a certain R value printed on the back of the insulation actually perform that way? Does it deliver that R value the way it's been installed? And so we're going to be talking about the details that make big differences. We're going to be talking about quality assurance, and we're going to be talking about inspection and testing on the back end to help ensure that we indeed get what we expect it to. So the goals of this program are all about saving energy and water and making your house a place that's nicer for you, costs less to operate, and so forth. We're also contributing toward meeting city goals. These are plans and policies that City Council have adopted around saving energy, saving water, and reducing greenhouse gas emissions. So a program like this has benefits both for direct participants who take advantage of the various parts of it, as well as the community as a whole. Another piece of this that's not right on the front page and not as obvious, but is very important, is workforce development. These contractors around the room, you'll be hearing more about them tonight. They're working with us on this program. They're our delivery mechanism for making the improvements. And in the past, on some of our other programs, we run into problems because we've had great ideas for programs, but we haven't had enough skilled contractors who are able to deliver the program in the way it was intended. And so we've put a lot more effort this time into designing contractor training and mentoring. I'll be talking a little more about that. But what we're trying to do is raise contractors' skill sets, give them the capability to deliver better products, a wider array of services with a focus on performance. And we're also hoping to open the door for more contractors as we help to generate more business through this program. So you've heard these terms, the green economy, the new energy economy. This kind of program is a piece of that. So another good spinoff, I think. Here's the three major elements of the program: audits, the improvements, and the evaluation. And as I said, I'm going to give you the one slide overview of the program you missed a couple of weeks ago. So in a nutshell, as part of this home efficiency program, there are two levels of audits offered. One is called the efficiency audit. The other is called the efficiency audit plus. The first one is a $60 audit. The second is a $150 audit. Here's an easy way to remember this. They're both great audits. They're both comprehensive. The efficiency audit is like going to your family doctor and getting a physical, okay? A fairly routine procedure. You kind of know what bases are going to be covered, and we give everybody a physical pretty much the same way. Same is true more or less of the efficiency audit for $60. So we'll cover the bases. We're just not going to be able to get too deep into any particular aspect of that. If there's some reason you think you'd like to go deeper on a particular part, get an efficiency audit plus, and you'll have the ability to work with that auditor to customize a little bit more, get the specific diagnostic testing in the areas you need, just like if you went to the specialist after going to the family doctor. And actually have the option to do the efficiency audit first, and then if you still want to learn more, you can pay the difference and get the plus auditor out there to work with you. Both of them generate a series of recommendations that are customized for you. They're prioritized based on what the auditors heard from you about your goals, your budget, as well as what they've observed in the house. So I think you'll find either of them very valuable. So that's what you missed 3 weeks ago. If you want to find out more about that, the program is taped. It's available on our website, fcgov.com/EPS. For Environmental Program Series, and you can find it there, and it'll also be aired on Channel 14, the city cable channel. All right, this is where we're going to be spending our time tonight. Remember, the goal of the home efficiency program is to make improvements. It's not to do audits, okay? We could do 500 audits, big deal. What we care about is that people follow through and make improvements, so that's what we're going to be focusing on tonight. And I'll be covering everything listed there: participating contractors, the eligible improvements, the installation standards, rebates, and also note that we at Utilities are available to answer questions as you go through the process. So support and coaching is part of what we're doing. Okay, and then the last piece I'm just going to touch on, we're not going to spend a lot of time on this tonight. Because this is an outcome-oriented program, we're accountable for producing results. We will be doing evaluation, third-party quality control on the jobs that are done. We'll be talking to customers, making follow-up calls after audits, after improvements are made to see how it went. We're definitely interested in having you call us, get in touch with any feedback. It's very valuable. And then gradually we'll be able to actually start measuring energy and water savings. So one very important part of this program are the contractors who, as I said, are really the delivery vehicle for this. And in our program, we call them participating contractors. It's kind of like approved contractors. And this is actually the first time that Fort Collins Utilities has put together any sort of essentially an endorsed list that gives these guys some recognition, gives them a pat on the back, says, you know, they're different from the rest of the contractors who aren't on this list. And we'll talk in the next slide about how they get on that list, what gives them the right to be listed here. This list can be found on our website. It's evolving. We've just been doing training, I think, for maybe about the last month now, and even a couple of days this week. So this list will be growing. I think there's 19 contractors on the list right now. Another 5 are expected by the end of the month, and probably add some as we go. The categories on the right side are the ones that you'll be able to see eventually here. They're not all up there yet, but insulation and air sealing, windows, window film, HVAC, which stands for heating, ventilation, and air conditioning, and then finally, hydronic specialists, people who deal with the water side of things. You can find this again at the program website. I'm going to give that address to you again. It's fcgov.com/home efficiency. What is a participating contractor? These are the guys who are wearing the performance glasses. They're the ones out there doing the work and getting the details right so that you get the results you expect. They're going to be standing behind their work. They work independently from the city. We're endorsing them as part of this program, but they are independent contractors. How do they get on this list? Well, they have to attend training that we sponsor. And even if you're a window contractor, you've got to learn about house as a system. If you're a heating contractor, you got to learn about house as a system. Everybody has to get that bigger picture view that sometimes hasn't been the case in the past. When you're a specialty contractor, you know a lot about what you do, but you may not know about how it affects other things in the house. So everybody gets that core training, as well as more specific training in their specialty area around installation standards, which I'll talk about in just a moment. And then we're going to have some ongoing mentoring to help ensure that what we teach in the classroom and in this initial training carries on in day-to-day work under this program. To be a participating contractor, you also need to be licensed with the City of Fort Collins. You need to be insured. You need to have an accredited status with the Better Business Bureau. You have to abide by a code of ethics. You have to offer at least a 1-year warranty on your work. And all this is governed by a legal agreement that they sign with the city. And we're going to work hard with these contractors to make this work for them. The mentoring is a good example of where we know it takes some time to learn some of these new practices that we're talking about. We want them to succeed. On the other hand, if we do have ongoing problems with a particular contractor, we've got a mechanism to take them off the list. It's not a guaranteed lifetime appointment. So I think we've thought this through pretty well, and I think it'll be a real benefit to you as consumers. Okay, let's talk about the improvements that are eligible under this program. And by eligible, I mean you potentially can get rebates for everything I'm going to list here. And I'm going to go through this pretty quickly. We're not going to talk about the details of any of this right now. I want you to understand kind of what the scope of what you can do under this program is. So the first thing we're going to talk about is elements of what we call the thermal shell, which is the envelope, the thing, the boundary of the house that separates you on the inside from the cold outdoors during the winter, okay? So crawl spaces are an example where we will provide some support. Basement walls, insulating basement walls, insulating exterior walls. Windows, either applying window films to control a solar gain or potentially replacing windows. Floors over garages, cantilever floors that go over the great outdoors. Attics and all the things that go with them. So when we're talking attics, we're talking about attic hatches and the leaks around them. We're talking about knee walls. We're talking about lots of things you find in attics. Cathedral ceilings. Okay, these are all components of the thermal shell, and when you look at them together, what you can see is that we're covering essentially that entire thermal shell. So there's opportunities to improve that, and we normally urge people to look at the shell of their house first. You can get multiple benefits from improving the shell, both in terms of comfort as well as energy savings. Then move on and think about the mechanical systems inside. So again, under this program, you can install whole house fans. You can replace the furnace. You can replace the boiler with higher efficiency models. You can install an evaporative cooler. You could install an air conditioner, a heat pump. You can replace the motor that drives the blower in your air handler. That can be a pretty good sized motor, and the conventional motors are not very efficient. This is a place, by upgrading the efficiency of that motor, you can save a lot of electricity. This is one of those hidden electrical users that most people don't pay any attention to, but can be a big part of your bill. Ductwork. We can support insulation and air sealing of ductwork that runs through unconditioned space through this program. We can help you replace your water heater with a more efficient or a safer model. We can help you install mechanical ventilation to provide a controlled flow of fresh air, controlled exhausting of pollutants from your house. So again, you put those shell improvements together and all the mechanical options that we can help you with under this program, and you've got a pretty complete whole house package. Okay, I mentioned installation standards earlier, and these are important. These are kind of the heart of the program, if you will. And these were developed in response to things that we see every day in Fort Collins homes, things that we see that compromise the performance of insulation and furnaces and air conditioner performance and so forth. So what these do is put the focus on the details, put the focus on getting those right in terms of achieving the type of home performance that I talked about earlier. We're trying to use industry's best practices here, and what these do is set a common understanding amongst you as the customer, we as the program sponsor, from the contractor's perspective who's got to install to meet these standards, from the trainer's perspective who's training to these standards, to the quality control people on the back end who are inspecting to these standards. So it's very important that we all are coming from the same perspective as to whether something's installed acceptably and in a way that it's going to perform the way that will deliver the rated performance of the product. The other way it can help is by leveling the playing field. I don't know how many of you got multiple bids from multiple contractors on jobs before? Probably a lot of us. And sometimes you look at the two bids and it's like, well, they're really different. I wonder whether they're bidding on the same thing. Well, this is going to help everybody bid a little more on the same thing. The prices may still vary, but at least you're getting a little more of an apples-to-apples bid. And then finally, remember, this program is funded by ratepayer money, so it's important to us that accountability piece I talked about earlier is important. We don't want to put ratepayer money toward projects that don't work. So that's why we spend a lot of effort putting together these installation standards. And I'm going to give you some examples of how these play out toward real improvements. I'd say a lot of projects that are done now and have been done in the past have been done with a low bid approach from the customer, okay? A lot of times you get those 3 bids and you pick the lowest cost. And that can work, and we're not saying you can't do that, but we're saying if you're going to play in our program, you're going to be kind of forced to go to best practices instead because of the installation standards. We're going to let you know right up front it's probably going to cost more to get the job done that way. And it makes some sense. The contractor has to be at a higher skill level. They had to spend time being trained. They're subject to the installation standards, which are pushing them to do things that they wouldn't have normally done. So yeah, it's probably going to cost more to get a job done to the installation standards working with one of these participating contractors than if you go out and get a bid on something that's sort of similar from a non-participating contractor. And you can go either direction you want. But again, if you want the rebate, you're going to go the best practice route. We know it's going to cost more, and that's why we're offering rebates to help offset some of that additional cost. We're offering rebates as Fort Collins Utilities under the Home Efficiency Program. There are also other financial incentives out there from Xcel Energy, which probably supplies gas for most of you. The Governor's Energy Office is talking about offering rebates, and there's a good chance that you'll be able to dip into multiple pots. We're going to know most about the ones that we offer. We can point you in the right direction to get information on the other rebates. It's a good time to be thinking about doing energy improvements. Okay, I want to show you a couple of examples here. The first one is crawl spaces. How many of you have a crawl space in your house? Quite a few. Of those who have crawl spaces, have any of you never been in your crawl space? Everybody being honest here? Okay, I figured there was a few more. I don't know anybody who likes to go into crawl spaces. Well, I shouldn't say that. Our auditors like to go into crawl spaces. That's why they're in this line of business. Some of our contractors love to go into crawl spaces. This is an example of a crawl space that wasn't very pleasant to go into. And it's a good thing to talk about because nobody likes to go in there, sometimes we don't see the highest quality of workmanship in crawl spaces. So I'm going to show you a series of slides here that illustrates what we see in Fort Collins crawl spaces and what we want to see, what the installation standards are going to direct. So for starters, we see moisture problems in some crawl spaces. A lot of crawl spaces are dry as a bone, but some are not. This one on the right here, Kim was in there last summer, I think, and there was evidence of water that had been actively flowing through this crawl space. Remember how wet it was last summer. And he went outside and he took this picture, and see there's a nice block there to direct water out from the gutter, but then it ran into the landscape edging that diverted the water right back into that gravel right next to the house, right into the crawl space. we don't want to support you to insulate a crawl space that's got water in it. You need to get that problem fixed. And so before you can take advantage of a crawl space rebate, we're going to say moisture sources have to be mitigated, whether it be getting the gutters working, the downspouts corrected, grading away from the house, that sort of thing. Here's something we see all the time. A crawl space that's insulated on the exterior wall, and then it's got some big vents punched to the outside. So is this crawl space inside? The insulation sort of suggests that, but we punched a hole to the outside, so I guess it's outside. Well, it's confused. It's a hybrid crawl space. It doesn't work very well. It's like, why bother putting the insulation there if you're going to punch a hole? So the installation standards are going to push you toward what we call a conditioned crawl space, which is insulated on the outside, doesn't have any vents. Think of it as a short basement. There are some other details you need to pay attention to make this work, but this is the most promising way usually to make crawl spaces perform well. We have some other ways we can talk to you about more on a case-by-case basis. Another piece of the moisture control is to put a barrier down on the ground to keep soil moisture down and not in the crawl space or up into the house. And what we frequently see is construction debris in crawl spaces. You saw that earlier picture. Here's one on the left that's got some sheet metal down there. We find all sorts of things in crawl spaces. And trying to lay a moisture barrier down over that and have it survive is not a good approach. We see it all the time. Similarly, we see a lot of sloppy work when it comes to moisture barriers. This one on the upper right, the tape is peeling off the seams. That moisture barrier had been in place for a few months when we saw that. The one on the lower right, the moisture barrier didn't quite make it to the wall. The moisture barrier could double as a radon membrane if it was installed carefully, a soil gas barrier. But that one on the lower right's not going to do that, neither is the one with the tape coming off. So the installation standards say, number one, you got to get the debris out of there first. You got to put down a heavy-duty plastic barrier. There's an example of a nylon reinforced one in the middle there. And then you need to take it up the wall, seal it, and mechanically fasten it to the wall. And something like this could double both as a moisture barrier and a radon barrier. So do double duty and be very durable. Take a look at that insulation there. Somebody bought the insulation, somebody paid for the person to put it in. The way that insulation is installed, it's not going to work. It might say R19 on it, and it might perform like R8 because of the way it's installed. It doesn't reach to the floor. There's gaps between the insulation on the wall, gaps between the insulation bats. Somebody wasted their money on this job. If you have a crawl space, go down and look, and you're going to find examples of this. I see it in almost every crawl space I go into in Fort Collins. So guess what? Details matter. We're going to say there are certain insulation materials you can use and others you can't. We're going to say that you've got to install these carefully so that they will function, so they'll actually deliver the rated R value. It's a matter of paying attention to the details. And if you do that, you're going to be eligible for rebates. Okay? In this case, in a crawl space, we have separate rebates for what we call the rim joist. That's where the floor above the crawl space meets the exterior wall. There's an element there that's kind of tough to deal with. And then separate rebates for the wall, the foundation wall, which is usually concrete. There's a range for each of these. There's also maximums. The center column says the rebate per square foot. The maximum rebate is an absolute maximum. And there's a range there depending on what materials you're using and whether you're heating with electricity or gas. I'll give you one more example. Here's a gas furnace. This is an oldie but goodie, probably, 40 years old maybe. Atmospheric furnace that's, if it's tuned up well, might be operating at 60% efficiency, something like that. So it'd be nice to get a more efficient furnace in there, of course. What we see in Fort Collins homes, we see a great variety of the way furnaces are put in, but I'll just give you some of the things we often see. Number one, there's been a lot of oversized equipment installed in the past. Furnaces that deliver more BTUs per hour than you need. The consequence of that is that they short cycle. They come on, blow hard for a little while, turn off. Blow hard for a little while, turn off. And this is not a way to promote either high efficiency or long life in a furnace. We see high efficiency condensing furnaces, great pieces of equipment installed like this one shown here. These things designed to use outside air directly into the combustion chamber and then exhaust products out, a very safe way of doing things. In this case, the place where the yellow arrow goes in, that's the intake air, and that's been stubbed off into the utility room. Probably saved a few bucks, but you've thrown away one of the advantages of having this furnace in terms of a house as a system perspective. We see furnaces that don't have enough airflow because they're poorly matched to the ductwork. And when you don't get enough airflow, you get a high heat rise. This is the increase in temperature as the air goes through the furnace. And again, you're throwing away efficiency, you're shortening equipment lifetime when you have high heat rise. And then finally, you may well have a conventional blower motor, which as I mentioned earlier, just is pretty mediocre on the efficiency scale. So you're missing the boat there. So in the installation standards in the home efficiency program, number one, the contractor is required to do load calculations and actually figure out how big the furnace needs to be given the rest of your house, the areas, the insulation values, the type of windows and so forth, and size the equipment accordingly. If you've got a furnace that's designed to be sealed combustion, it's got to be set up, as you see in the right-hand one, where you got a hard pipe coming in and a hard pipe going out. And then finally, the equipment has to be commissioned. We're going to measure heat rise, we're going to measure airflow, we're going to make sure that the furnace is operating as installed in your house to deliver the efficiency that it says on the label, safely, without excessive carbon monoxide production and things like that. There's a big difference often between what it says on the label and how it performs in real world, and we're trying to get those closer together with this program. And here are the rebates. There are 2 levels of rebate depending on the efficiency level you choose, and in the higher efficiency one, you also have to go for the efficient electric motor, and you get a couple $100 more on the rebate. So I hope you can see these rebates are substantial. They're intended to encourage you to get stuff installed in your house that you might not otherwise and get it installed correctly. A few details, important details. To take advantage of this, you need to be one of our customers on the electric side. We have some people who get Fort Collins Utilities water but not electricity, and unfortunately you're not eligible to participate in the program. This is for single family homes at this point, single family detached or attached housing. You are required to get a home efficiency program audit first. You will learn a lot about your house in the process, and often people decide after having the audit to get a different combination of things than they thought they were going to get before they had the audit done, because they've learned so much about how their house works and where the opportunities are. You need to deal with a participating contractor, some of whom are here tonight. Do-it-yourself, unfortunately, is not eligible. Because we're putting so much emphasis on these installation standards, this stuff is not no-brainers. These guys who are spending the time to get the training, they're the ones who we're working with to make this program work. There are some rebates for which there are limits on whether you're eligible depending what's there already. In some cases, if you have a certain amount of insulation and a certain component already, we're not going to subsidize putting more on. And again, this is where we get into the details of the rebates that we'll be glad to talk with you about kind of one-on-one. I don't think we're going to spend everybody's time to learn about every rebate. There's a few measures where things get a little tricky, where we're going to require pre-approval. Generally, pre-approval is not required, but there are a few. And again, if you look at the website rebate list, we'll try to make that clear. Work per installation standards, we've talked about that. The rebate amounts are on the website. Again, fcgov.com/home efficiency is where you find all this information. And again, other incentives might apply beyond the Fort Collins ones. So just a couple last things here. I want to reinforce, we're looking at this from a whole house perspective, and we hope you are too. That's why we have programs like this to help you see the value in this kind of perspective, the performance perspective. We've talked about the shell, we've talked about the mechanical equipment. I also want to remind you that what you put in the house is very important. And we've got some specific financial incentives around efficient lighting through retail partners here in town. Energy Star dishwashers and clothes washers, again, with retail partners. And there's a new rebate on low flush toilets, which you can take advantage of. I think it's $35 for a low flush toilet, and I think it's another $15 if you recycle your old toilet to go become road base here in Fort Collins. So that's a good opportunity. And then there's lots of other things you can pay attention to inside your house on your own to control both electric and gas use. and water use. Because we do understand pretty well now how houses work, we understand some of the complications you run into in houses. We know that some of those things can change as work's done on your house. So we're going to be looking carefully at combustion safety, and I think Jeff's going to be talking about that. And then mechanical ventilation is also something that may become important for you. And I wanted to let you know we're going to be looking at those things. We do offer rebates to help you solve problems related to those issues. And I think importantly, a lot of people kind of gloss over these things and hope they're not problems. We know other programs here in the state that are kind of turning their back on these issues because they're complicated. We think it's important that we look at them and that you know if we find a problem. We're going to encourage you to solve these problems if we do find them. You're not going to be required to, but if you don't, we're going to ask you to sign a disclosure form that says, at least we told you about them. Okay, you need to acknowledge that you heard about them from people involved with this program. Because it's in your best interest to deal with them, and it's in our best interest to have told you about them.
Hello, everybody. Where to start? Want to make my house more efficient, more comfortable? There's a big list of things up there. Which one are we going to start with and why? Now, if your furnace is failing, if you've got hot water running all over your floor, well, you know where you're going to start. From the audience, what do you think? Is there something that you should do before you do insulation? Just from this list. Okay, here's some sealing, some air sealing. Sure, that's a real good thing to do before you do insulation. A lot of times we've got to go up there and push the insulation out of the way to do the air sealing. Sometimes we have to vacuum it out of the way. Yeah, wiring upgrades, and I put that one up there just to cover before you do the insulation or the air sealing. We're talking about the electrical wiring in your house. So especially if you've got an older house, it may be time to think about upgrading the services. A lot of times your homeowner's insurance will go down. If your home's over 40 years old and you rewire your house, your homeowner's insurance will go down. I think the actuaries have worked out the numbers as far as what burns houses down, so they'll give you a break for rewiring. And also air sealing. We air seal a house up nice and tight, and then we need to add ventilation, a constant level of ventilation instead of that natural level that fluctuates high and low depending on the weather. Okay, so just some of the things to think about as you're getting started here. You may be working with multiple contractors and you want to review this type of thing with your contractor. Again, if you've got a water heater failing, well, that's a place you need to go to right away. But if you put in a water heater that the city program is rebating, a power vent or a sealed combustion water heater, you could eliminate some problems later with your combustion appliance zone. Doug was talking just briefly about that, and we'll cover that later. But what if you've got a water heater that's spilling combustion byproducts into the house? Or what if you're going to do air sealing that could affect that water heater in that way? So I'd like to get you guys to think ahead a little bit when you're implementing a furnace and air conditioner, that whole list we had there, how that affects the other things in the house, and if you can make the right decisions now that are going to help you out later if you consider the house as a project, not that we have to take the whole house on in 1 year. So let's go ahead and move on to some examples, and we'll start out with the basics, the insulation and air sealing. And this is definitely the basic one. No insulation in the walls. You probably don't need an auditor to tell you that. You guys probably know that already. You have cold rooms, very cold rooms in the winter, and they fluctuate. One part of the house is hot and the other part is cold. Get the walls insulated. Here's a house we did. It was an all brick house. A little hard to insulate the walls, but we got it done. The first year, 32% reduction in natural gas usage. So that's a substantial amount right there. It's about a third. Homeowners saying, my rooms are evenly heated. I can go in all the rooms and they're all about the same temperature. And then kind of the surprise for them was that they don't hear the traffic noise. This was a house that we re-insulated, or we insulated with cellulose, a dense packed cellulose. And that's one of the advantages of using that type of insulation in the walls. Air sealing. So air is moving through our house, and I just happened to be up in this attic on a cold winter day. It was cold up in the attic, and it was moist in the house. And if you take a look at that lower picture, you can see a cloud forming. Basically, that's moisture from in the house coming up into the attic and turning into a cloud. It's neat to get to see these pictures. I can say, unless your house was built just recently, all of your houses could use some attic air sealing. Sealing the attic from the house to help make that more efficient. Here's one way to do it, or at least two ways to do it. The picture on the left, you can see that's using caulk. This is just a drop-down soffit. You could reach your arm right down into the walls in this house from the attic. That's a big thermal bypass. So we just put blocking over the top of it and then caulked it. The second photo is just, standard, a lot of this type of stuff. That's the top plate, so that's just an interior partition wall up in the attic. That's what they look like. You've got the drywall on each side, and then this we use 2-part foam to cover. That's not, you don't get great benefits for doing that, but you do get some, because a lot of times there's a 32nd or 16th of an inch gap all the way down both sides of that wall. You can have 500 foot of a 32nd of an inch gap. And so it does make a difference on your blower door number. Let's look at something that's a lot more precise. Again, we're up in an attic. The steel pipes there is a furnace. Actually, that's not true. That's a water heater flue pipe. And the thermal image shows, this was taken in the summer. So over here, the roof deck, it's over 105 degrees. And this is cold air from the house coming up into the attic. It's below 90 degrees right here. So we know there's a problem here. Let's take a look at it. We'll uncover the insulation. So what they did was they had wrapped fiberglass insulation around this chase. And right there, again, we're reaching our hand into the house from somewhere outside the house. That needs to be fixed. Your air sealing contractors know these type of things. The auditors should be finding them when they're up in the attic, something this large. The fix, sheet metal cap, high temperature caulk around the flue. The protective cap, protective ring around the flue pipe is only necessary with certain types of B vents, so you're not going to always see that, and then re-insulated. Let's look at a fireplace. The numbers on the left indicate a blower door number. So we're going to use, the auditors will use a blower door to get you a leakage number for your house, that CFM50 number. So this is a CFM50 number before and after. This was a fireplace retrofit. This fireplace set on the outside of the house in a bump out. Back came off, new fireplace went in, insulation, air sealing in that fireplace chase. We got about a quarter of the air leakage right there, not to say about the advantages to having the extra insulation in too. Here's a good one. This is a room over garage. This would be a newer house typically, so it doesn't always happen in the older houses. If you look at that IR picture, let's look at the colors in here. The warmest spot in this picture was 54 degrees. Was that room comfortable for those children that were in that room? Absolutely not. This room was running about 7 degrees below the rest of the house. Actually, there are 2 rooms above the garage, and so this is one of them. So what's going on here? Well, let's move forward. We just dove down underneath the floor, and so we're underneath that floor looking, and what do you see? Got some insulation in there. It's actually about that thick, so that should be enough insulation to do the job. What's wrong with it? Does anybody know? There's a air gap. That's right. The insulation is not in contact with the air barrier. So what's happening in this case is that outside air is running underneath the floors of these bedrooms. So that insulation basically is ineffective. It's out of the picture. Move on to the fix. This was a more involved fix in the sense right back here. This is the room that we're looking in the garage, looking up. It was a finished garage. There's that insulation that we were just looking at. Again, all these bays, you can stick your arm into the house. Block air seal. This is that supply register. We move that right up against the floor, and here we build the chase down. This was an OSB chase. We drop that down so that we can get insulation underneath that supply register. This is an air sealing, so the wall to the garage attic, we pulled up the insulation and air sealed that to take care of the air that was coming underneath the baseboard and that type of thing. In the end, those rooms turned out to be just as warm as the rest of the house once it were done. The children were very happy that they completed that. We'll take a look at the heating, ventilation, and air conditioning side of things, more commonly known in the trades as HVAC. This was a simple fix. for a house we completed last summer. All that the homeowner wanted to do, she wanted to do just the basic minimum that she could. So we addressed the duct leakage to outside. Basically, duct leakage to outside. What does duct leakage to outside mean? Well, what are ducts? We know what the ducts are. So the ductwork distributes the air from your furnace and or your air conditioner around your house. Now, that duct system is designed, or it should be designed, to deliver the inside air, right? There's a return in your house, or multiple returns. It pulls the air from the house through the furnace, and then it delivers it back to your house. So this is a closed loop. When we're talking about duct leakage to outside, we're talking about a duct system that's pulling in outside air, or it's taking heated air and delivering it outside. Doesn't do real good on your energy bill when you're trying to heat northern Colorado. So, simple fix. This was return side duct sealing. So any of the HVAC contractors here can be able to help you out with something like this. 15% reduction in natural gas, and she did have a 20% reduction in electric usage. Now, I'm not going to claim that with my duct leakage to outside, because we also talked to the homeowner about standby loads in her house and unplugging things. That's probably has more to do with it. Maybe she bought the LED Christmas lights this year instead of that. But you know, a 15% reduction in your utility bill, that's not anything to sneeze at, especially when it's one fix. It's just one thing to do. So you add a couple of those up, and you could be down 30-40% on your house. That was kind of a conceptual thing there, that duct leakage to outside. Let's look at a picture here. So we did some heating, so how about some ventilation? If you look in the back of this slide right here, this is an exhaust fan installed in a bathroom. The homeowner wanted a good one installed, so that duct is a 6-inch duct. Most of the time we're looking at a 3 or a 4-inch duct. Can somebody tell me what the problem with this duct is? Exactly, we have some condensation going on, and somebody else said something back here. Okay, not insulated, and there's a real big one. That's right, that's it right there. This duct should go through the roof, and it should vent to the outside. This duct ends in the attic. See this picture over here? This is just off to the right of that other picture. This is the roof deck. Again, this is a winter day. You got it. That's ice and icicles forming on the inside of the roof deck from moisture from her bathroom exhaust fan. This is just one of the things. Any of these contractors here have been through the training. Certainly the city is not going to rebate an install like this. So that's, I guess, a plug for the city program and for getting a contractor to do it right instead of just doing it. Here's another way to do ventilation. Right here we've got 2 pipes. This is a heat recovery ventilator. We can do exhaust-only ventilation. This heat recovery ventilator takes outside air, brings it into the house, and takes the inside air and takes it back outside. Now in that process, inside that box, it runs it through a heat exchanger, so it transfers some of the heat from the house in the winter, or the, I guess, heat from outside in the summer. So you get a recovery rate. So it's not just, you're not just venting the heated air in your house outside, you're actually capturing some of that heat. So it's a 2-pipe system. I should say this one is a 2-pipe system. A lot of them, if they go in the mechanical room, are a 4-pipe system. So this would be the Cadillac as far as ventilation goes. Not one of those necessities. If ventilation is required, there's other ways to do it, but it is an option. Heating, ventilation, let's go on to air conditioning. This was a house we looked at. The audit found that the furnace and air conditioner efficiency were low. We had an air conditioner coil that was plugged up, which resulted in the low airflow through the inside of the system. And actually that's why your efficiencies were low. The limit switches, we'll cover that in just a minute. That means that the furnace, well, how does your furnace, what turns your furnace on and off? And that's the thermostat. You say, I want 70 degrees. When it's below 70 degrees in your house, it sends a signal down to the furnace and it comes on. And that furnace should stay on until your house reaches 70 degrees and then turn off. Okay, this furnace, the blower stayed on, but the burner would come on for 1 minute and 45 seconds. The burner would turn off for about 2 minutes, and then the burner would come back on for another minute and 45 seconds. It would repeat this cycle over and over. Basically what was happening was the indoor airflow was so low, the amount of heat we were putting into the furnace was overheating the furnace, and this high temperature limit switch was shutting the furnace down every minute and 45 seconds. So that it's a safety switch, so that you don't have a fire in your furnace. Again, low airflow was the primary cause of this. So the other thing the audit found in this house was the ductwork was almost adequate for the house. And the good news for this homeowner, this is a maintenance issue. This is not I have to take a furnace out or I have to change my ductwork. We'll take a look here. This is an air conditioning coil. It sits on top of the furnace. This is the air conditioning coil after it was cleaned by an HVAC contractor. Now that HVAC contractor is not in this room, and I'm sure the HVAC contractors in here would not do this job. But let's just take a look down at the furnace. Again, this is after it's cleaned. This is dirty. And this air conditioning coil is plugged up. We measure pressure in the audit, and the pressure went from 0.42 to 0.39 after it was cleaned. It should have been down at 0.26. So that's why we took it apart to take these pictures. So there's a picture on the cleaned coil. So when you're working with your contractors, you need to ask them, how do I know you're going to do a good job? Tell me how I know as a homeowner, as not an expert in your field, what are you going to measure, what are you going to test to tell me that's going to tell me that this job has been done correctly. The Fort Collins program supports that with the audits on the front end, the contractors doing the work, and the test out on the back end. So that's built into the program here in the city. For the engineers in the room, we can kind of go over the numbers. Cleaning the coil, we actually changed out a filter also. The flow went from 262 to 383 standard cubic feet per minute per ton. Now you're saying, what's that? Let me just tell you, nominal is 400. In Colorado, we like to see 450, 480. So we still didn't quite get to where we wanted to be, but we're a whole lot closer. The efficiency of this air conditioner is running at 9 energy ratio. It's designed to run at 11, so we didn't quite get it to where we'd like to see it. And again, it's a combination of the system is still a little bit oversized for the ductwork. Now the heating efficiency, remember we were saying that furnace was shutting down every minute and 45 seconds? So my 80% furnace is running more like a mid-70s, like the number came out 73%. And so just by getting this air conditioning coil clean and changing the filter, we went from 73% to 80% on the furnace, and the air conditioner went up to 9 on the energy ratio. We're estimating it was about 6 before we did the retrofit here. So it's just important on these, well, it's important, these things are systems. The furnace and the air conditioner and the ductwork, it's a system, they work together. They may have been installed by different contractors, but when those contractors put those two systems together, they need to check that interface and make sure they're putting the right size furnace, the right size air conditioner with the right size ductwork. Here's an example of another filter. We've had this in a house. Pressure drop across the filter, 0.47. That's huge. The pressure drop across the whole system, the return ductwork, the filter, through the furnace heat exchanger, through the air conditioner coil, and then back out to the supplies, should be below 0.5. Just one item in that chain is almost 0.5 already. We have, I'll give you, the after is just a standard filter. That pressure drop was 0.11. So I did bring a filter real quick for a demo. Tell you what, I'll let you hold this end. I want you to grab this end and just come over this way, and let's see if we can pull this thing apart. I kind of cut it here, right here. All right, there we go. So that picture in that photo is 20 by 25 by 1 inch. And so it does have pleats. That picture is about this long as far as the media in it. This is a 4-inch filter. You can see, so the same 20 by 25, but the air is moving through all this surface area. It's a fiberglass filter instead of a paper filter. There's a whole lot less resistance. So if you desire in your house that your furnace and HVAC system cleans your air, you need to talk to some of these HVAC contractors and get to install a filter similar to this. Okay, thanks guys. So we'll bring it back around to the house as a system. Combustion safety. This is the top of a water heater. This is the top of a lot of water heaters in Fort Collins when they start up. This spot right here is called the draft hood. And the idea is this is dilution air. The burner is down below, hot air flows up and out this chimney by design. This draft hood is designed if you get a gust of wind or something like that, the air can come down the chimney and go out without blowing out the pilot light. In this case, what's happening is some of that combustion byproducts, this has gone through the burner, I mean this is exhaust gas, is spilling into the house. That smoke in that picture should be going up the draft hood and up the chimney. We're going to hit this. Carbon monoxide is a byproduct of burning a hydrocarbon. Depending on how well the burner is running, how much carbon monoxide you get. But let's just, I mean, you guys are kind of reading that. Headache, vertigo, weakness, irritability. This is acute exposure. The next slide is chronic exposure, so repeated exposure to carbon monoxide gas. Anorexia is loss of appetite. Lassitude, I had to look that one up. Basically, the easiest way I remember it was lackadaisical, so I'm sure there's a doctor in here that could help me define that more. Ataxia, that's a nervous system disorder. You lose control of your voluntary muscles. Your brain says, I want to move this muscle, and it's not moving the way I want to move it. So carbon monoxide poisoning can be a serious issue. Certainly, if you've got some of these symptoms, here's some resources. These will be in the presentation on the website. You can hit that. Fire department's the first one to call. They can get over to your house right away. Obviously, it's kind of the first thing, get out of the house. So let's take a look at the combustion safety testing we've done. So it's a part of the audit, and then as a part of after retrofits are done. So if they're doing air sealing on your house, this test is going to be done in the test out phase before you get your rebate for the city of Fort Collins. 45% of the houses that we did failed the combustion safety test. That means that picture at the beginning with the combustion byproduct spilling into the house, that was happening for at least 60 seconds. So over a minute on startup, we were spilling combustion byproducts into the house. So it's a serious issue. I mean, and I applaud the city of Fort Collins for putting it in their program and putting it, rebating only if this safety issue has been addressed. Let's go on windows, back to the shell. Let's talk about your summer heating load and your air conditioning load and the summer heating. If you've got these east and west windows, your house is getting hot. One of the main drivers for that is the sun coming in the windows. A new window will help you with that, and solar heat gain coefficient is something you'd like to look at for a new window. You've also got some window tinting options that will do that same type of thing as far as the solar heat gain. So that stops, the whole idea is to stop the sun before it enters the house. Blinds on the inside help a little bit. Blinds on the outside help a lot. Exterior shading helps a lot. Solar heat gain coefficients on the new windows, you're seeing in the 0.33, so 30%-ish of that sun is getting in that window. So it's blocking 70% of that. And the third generation Lowy window, you're seeing a visible transmittance of 66%. So that means, well, let's just go back. The prior generation, the visible transmittance of a high solar heat gain window was 42%. 42% of the visible was coming through, and before that, they were, I think, in the mid-30s. So to get a window that blocked a third of the solar heat, it also blocked, or 2/3 of the visible heat, it also blocked 2/3 of the visible light. The windows these days can block 2/3 of the solar gain and still give you only block 1/3 of the visible range. So they're a real nice addition to a house. We'll talk about electricity real quick as part of the audits. This is watts over here. So that's 200 watts, 400, 600, 800, 1,000. Electric standby load, this is how I define it. This is from our audits. So we'll do an audit, come into your house and say, okay, I want you to turn all the lights off and I want you to turn your appliances off. So just turn everything off. And then we measure how much electricity your house is using. I think our average was like 590 watts. So your house is using 590 watts when you got everything turned off. There's stuff plugged in that's using electricity. Kind of the groupings here, these low, I think the lowest was 49, and then there's a 55 in here too. These people have gotten on it. And they've basically unplugged things, they've switched things. So all that's left, is the furnace, the garage door opener, the oven and the stove and all the microwave, those are all plugged in. But these people have gotten on it, and they've gotten down to where, the stereos and that type of thing are shut off. Or I should say that the new Energy Star televisions and stuff, they use milliwatts when they're off. Your old televisions, I've measured televisions at 35 watts. I've measured digital cable boxes at 65 watts. When they're off, it all adds up. And you can see we've got some really quite high users, 1600 watts. This is one of the things you can do to make a real difference on your electric bill, as to unplug or get the items switched that run 24/7. You've just got an item that comes on strong, but it's only for an hour a day. Well, that item that's running low electricity for 24 hours a day, 365 days a year, probably adds up to more in your electric bill than that one big appliance. So there's my contact information, and so thank you very much.
Okay, so the question is, what causes water heaters to backdraft? And the answer is, could be several things. The way the water heaters that most of us had, natural gas water heaters we're talking about here, the way these things work is they're burning natural gas mixed with air down the burner, and the heat from that flame and the exhaust products travel up inside the water heater, transferring heat to the water inside as they go. But that flue gas has to be hot enough to keep rising through the flue and out through your roof. It's just buoyancy. The exhaust gases are warmer than what's outside, and it's like a hot air balloon trying to rise. So that's how it's supposed to work. It turns out that the pressure that's pushing that flue gas out is very tiny. Jeff talked in our Part 1 program about the types of the magnitudes of the pressures that we measure when we go into houses and do some of these diagnostics. They are incredibly tiny pressures pushing that gas out. The bad news about that is it's easy to create negative pressure in your house that is bigger than the positive pressure pushing that gas out. What are some of the things you guys can think of that would create a negative pressure in your house? A whole house fan, that's a good example. If you turn the whole house fan on, you're pulling a large volume of air out, and it's making a negative pressure. That makes a big negative pressure. Box fan in a window, very similar to a whole house fan. How about a radon fan? That's a good one. A dryer, a bath fan, a kitchen hood. Those are all fans that are pulling air out of your house. It doesn't take much pulled out to drop the pressure, because remember, we're talking about tiny, tiny pressures. So those are pretty easy to understand. Another one that we run into a lot is leakage in your return ductwork. Okay, this is the ductwork that's bringing air back to your furnace. There's a big blower in your furnace, and on the return side, that blower is pulling air back through that duct, right? Does that make sense? If you have a leak in that duct, then all of a sudden you've depressurized the space that duct travels through. And the most powerful pressures are right near the furnace. And guess what's located near your furnace usually? The water heater. So when these guys do their combustion safety testing, they turn on fans, they turn on the furnace in a prescribed order to help them understand what's causing the problem. So that's where we need some training. That's where we need to have our brains working. And there are other things that contribute too, but those are some of the most common. Then the question is, okay, so you find a combustion safety problem. As Jeff says, 45% of the water heaters he's tested fail the test. That's not good news. So what do you do about it? Well, you can try to address the source of that negative pressure. That's one thing you can do. Does that mean you're never going to use your bath fan? It's challenging. If you know it's due to return leakage, there are some things you can do. You can patch the duct, or you can seal the ductwork. Not with duct tape. Don't use duct tape. Use a durable material like mastic. So that's one you can deal with. I guess one problem we didn't mention is the pitch of the flue can make a difference. The size of the flue can make a difference. There are lots of things that can affect it. Let me get to the bottom line. What we provide rebates for are safer water heaters that don't work the way I described. Instead, they've got a fan that's pulling the exhaust products out of the house or pushing them out forcibly. So a power vented water heater is a good first step. That's your lower cost option, or some sort of sealed combustion water heater, like the furnace I showed earlier was an example of a sealed combustion unit with outside air directly piped into the furnace through a sealed combustion chamber out through a hard pipe to outside. That is virtually immune to backdrafting. You can get the same kind of approach on a water heater. Yeah, they're more expensive than the standard water heater. Once you start understanding this, when I built a house 15 years ago, I knew about this stuff. I didn't even consider putting in a standard water heater in my house. I'm not willing to take that risk. So there's no easy answer, but the easiest solutions and the ones that are most likely to solve the problem are the equipment change out. Other questions? Sorry, that was a long answer, but it's a good example of this house as a system stuff and why we train these guys about this stuff and why we require testing and so forth. Yeah. Okay, the question is high efficiency blower motors. Is there any rule of thumb about when to replace your blower motor for higher efficiency versus replacing the furnace as a whole with a higher efficiency unit that has a higher efficiency motor? The best application for a high efficiency motor is in applications where the motor runs a lot. So if you're one of these people who has your thermostat fan switch set to on instead of auto, so it's running 24/7, you're running a lot of hours, and that's when you're going to get the best efficiency or the best payback on that higher efficiency motor. And as he said, if you've already got a furnace that on the combustion side, on the heating side, is relatively high efficient, that you're happy with, just replace the motor. If you're thinking about replacing your furnace anyway to get higher efficiency, or you have an older furnace, if you had a 15-year-old furnace, it probably wouldn't make much sense. But if you got a 5-year-old furnace and you're running a lot of hours, run the fan a lot of hours, that would be a great candidate for changing it out. Don't you hate that? Two different sources of information giving you exactly conflicting answer. Her question is about crawl space vents. The home inspector says you got to have them. The weatherization people say you don't. Let's take a poll here. I'm curious. How many people think crawl spaces should have vents? Couple. Depends on what? Depends on radon. Maybe. How many people think they shouldn't have vents? I already gave you a hint on this one earlier if you guys were paying attention. We don't want vents in there. This is a great example of where we've learned more over the years. For years, the building code required crawl space to be vented. And the idea was that if you got moisture coming up from the ground, you get rid of it by having vents, and the air moves through from outside from one side and goes out the other side, taking the moisture with it. Smart arrows, we call them when we draw those on diagrams of houses. But air isn't quite that, air is pretty smart. It knows how to go from high pressure to low pressure. So what we found when we actually started doing measurements was that what those vents served at was big leaks in your house, because during the winter, in particular, when it's warm inside and colder outside, it's just like we were talking about with the water heater earlier, the house inside your air, the air inside your house wants to go up, and it goes up and escapes through the leaks that Jeff showed us in the attic. So the common pattern during the winter, when the wind's not blowing, which actually, believe it or not here, is most of the time, the wind doesn't blow very much, air is leaking out the top of your house, and it's coming in through the low points in your house. And guess what? A crawl space vent is a beautiful place for an air leak. So we found out that instead of removing moisture from your house, the crawl space vents make it easier for whatever's in your crawl space to move into your house or even into your attic. People have found rotting roof decks from moisture in crawl spaces carried up by what we call the stack effect. So the short answer, I guess, is that we've learned a lot, and crawl spaces don't work the way we used to think they worked, and maybe the arrows haven't gotten any smarter, but we have.